Hello everybody, it's Mr. Joseph. Today we are going to solve rational equations, but before we do that, we need to make sure to practice just solving some general equations. So the first one is a linear set equal to a linear function, so we should expect one answer when we do this. So we're going to do number one, and that's 2x minus 5 equals 10 minus 3x. When we do these type of problems, we want variables on one side, numbers on the other side. So the first thing I'm going to do is add 3x to both sides. And you're going to get 5x minus 5 equals 10. Then you're going to add 5 to both sides. And you're going to get 5x equals 15. And then you're going to divide both sides by 5. And you get x equals 3. So this is an example of how to solve an equation, and this is a linear function equal to a linear function, so we should expect one answer. Like always, I suggest that you try these problems before actually watching the video, so you can kind of pause before I do it. So we're going to do number 2, and we have a quadratic equal to a quadratic. So something to really pay attention to in this problem is the fact that isolating variables on one side and getting numbers on the other side is not as helpful on this problem. Because we see this power of 2, this makes me feel like we can use, we can factor in this problem and probably set it equal to 0 and find some solutions that way. So what we're going to do is we're going to add x squared to both sides, which is 2x squared minus 5x plus 5 equals 3. Then we're going to subtract 3, and we get 2x squared minus 5x plus 2 equals 0. So remember what I said earlier, that we should expect probably something that we could factor. So I'm going to write my 2 parentheses. And I know the first 2 terms have to be 2x and x, because 2x times x gives me 2x squared. I know that both numbers need to multiply to give me a positive 2, but I see in the middle I have a negative 5 as a sum, so I know that they most likely have to be both negative in order to get that positive. So I'm going to make this a negative 2 and this a negative 1. And I can check that this is correct, because if I do 2x times negative 2, that's negative 4x. And if I do negative 1 times x, that's negative 1x. I know that negative 4x minus 1x is negative 5 in the middle. And I know that negative 1 times negative 2 is positive 2. So I kind of check the middle to make sure my sum is negative 5. And I check the last 2 numbers to make sure that multiplies to 2. So I'm going to undo all that so I can actually set these equal to 0 and solve it. Okay. So now to solve it, you take each factor and set it equal to 0. So for this one, we're going to get x equals 2. And for this one, we're going to add 1 and divide by 2 and get a half. So remember, I'm going just a little faster than usual. This is our warm-up. I want us to be comfortable with this, and you can always kind of rewind and slow it down. But this is kind of what I expect you to know how to do, and you're going to see how this incorporates to what we do later on. So now we're going to actually start the lesson, and like I said, this unit is called solving rational equations. So we're going to do number 1 together, and I kind of listed 3 methods to do this problem. And the first method is called guess and check. So if I have 3/5 equals x over 20, I want to find an x value that makes both of these fractions equal. So I know that 3 over 5, for instance, is the same thing as 0.60 or 60%. So in my head, I can ask myself, if I had 20 problems on a test, how many do I have to write? How many do I need to get right to make a 60? And I could have guessed that x equals 12. because 12 over 20 equals 0.60. And also you can think of it as 10 over 20 is 50%, so 11 over 20 is 55%, 12 over 20 is 60%. So the answer is 12, and that is using method 1, which is guess and check. But that's probably going to be our least favorite option unless it's really obvious. So I really don't recommend it, but it is something that you can do. So we're going to get to our second option, and I'll actually label this one. We're going to do method 2, which is cross multiplying. So when we cross multiply, we multiply this way. So you end up with 5x equals 60. And remember, we're getting 5x by doing 5 times x. We're getting 60 by doing 20 times 3. Then we're going to divide both sides by 5, and we get x equals 12. So that's called cross multiplication. I feel like that is a method that we're familiar with, so you might like that option. So method 3, which we're going to kind of introduce today as something new, is one of my favorites. So what we do is we make both denominators the same. So I'm going to multiply this by 4 and this by 4 because 5 and 20, the lowest common multiple is 20. So I'm going to get 12 over 20 equals x over 20. And I'm not sure if you noticed, but both of these have the same denominators. So all you have to do is set the top equal to each other. So when I say it like that, it makes people feel like it's just a shortcut. And I want to show you in reality that I'm just multiplying both sides by 20. And whenever you have the same denominators, they're always going to divide out. And you can always set the top equal to each other. And we're going to see that as we keep going along this lesson of why I'm not always going to show the times 20 part. Because I'm just not. Because you're just going to see once you do it over and over again that it becomes something more obvious. So as we go through this lesson, I want you to think about method 2 and method 3. These are going to be the two methods that we use, and I want you to think about what is the best method to solve a problem. So I'm going to go to problem 2, which is this one right here. So I can easily put this over 1, and I'm going to choose to cross multiply on this one because it's a fraction equal to a fraction. It's not anything crazy. So I'm going to do 2 times x minus 3 equals x times 1. And I hope you noticed that I said 2 times x minus 3, and I treated that like as a whole term. And this 2 multiplies each one of these, which is 2x minus 6 equals x. Once again, I want to have my x's on the same side and my numbers on the other side, since this is kind of like a linear, equal to a linear. So I'm going to subtract x, and I get x minus 6 equals 0. Then I'm going to add 6, and I get x equals 6. So that is the cross multiplying method. The second way, once again, was we call it canceling the denominator. So I'm going to write the question again. I'm going to write 2 over 1. What you do is you multiply this by x minus 3, this by x minus 3. You notice that these are both the same, so you can kind of ignore them and set the top equal to each other. But when you do this, you're going to get the exact same thing. I'm not actually going to finish the rest of this problem. Well, I might as well. I'll subtract 2x, get negative x equals negative 6, and then divide by negative 1, and I'll get 6, which are both the same. Once again, I want you to determine which one you think is better. In this case, I think both of them work equally well here. So I'm going to go to the next one, which is this one. Once again, I think just cross multiplying here is probably just the easiest method to do, and I will just do that. And once again, I would try these problems if I were you. I'm just trying to get you comfortable with the math. And as you can see, I'm distributing my numbers to each part of my binomial. I see I have 20x plus 90 equals 36x plus 42. I am going to subtract 20x from both sides, and I get 90 equals 16x plus 42. I'm going to subtract 42. And if I do that, that becomes 10. That becomes 8. So I get 48 equals 16x. Then divide both sides by 16. And I get x equals 3. A nice number. So at this point, I hope you're feeling more comfortable. You're like, okay, I see this. This makes sense. And let's see if we're going to turn up a little bit on this problem, which we most definitely will do. So we have this problem right here, and now comes the conflict of what's the best way to do this. So do I cross multiply here? Interesting. So what I'm going to do is I'm going to choose not to cross multiply here. I'm going to choose the method canceling the denominator. I don't know what. Denominator. Okay, so what I'm going to do is I'm going to factor first. So I'm going to highlight this in yellow. So when I look at 2x minus 2, I notice that they both have a 2 in common. So I'm going to factor out a 2. And I'm going to write x minus 1. 2 times x is 2x. 2 times negative 1 is negative 2. So all I'm doing right now is I am factoring just to see if there's anything that I can notice about my denominators. I then look over here, which is x squared minus 1. And I notice the difference of squares. So it should be x minus 1, x plus 1. And when I see this, I'm going to put a smiley face under x minus 1 because they both have that in common. Remember, in order for my denominators to kind of go away, or for me to get rid of the denominators by multiplying both sides by the lowest common multiple, they need to be the same. As we can see, this left side is missing an x plus 1. So I'm going to give this an x plus 1. This side is missing a 2. And this is missing a 2. Just remember that whatever you multiply the denominator by, you have to multiply the numerator by, because x plus 1 divided by x plus 1 is technically 1. 2 divided by 2 is technically 1. We are not technically changing the value of what we are doing. So we're kind of cheating in this way. So if we look at our denominators, we see that they're both the same. So you can ignore the denominators and just set the top equal to each other. And when you do this, let me not just do shortcuts. You get this. When you distribute, you get 5x plus 5 equals 30. Subtract 5. And then divide 5. And you get x equals 5 as your answer. So, as you can see, it gets fun here. I think canceling the denominator is definitely a good method here. You could have used cross multiplication, but you're going to see that that would have been a little harder to do than this. So we're going to get to our last question, which we now have 3 terms in total. We are not going to freak out. All we're going to do is focus on this part right here, which is x squared minus 7x plus 12. So we're going to factor that. So what 2 numbers multiply to 12 and add to negative 7? Well, that's x minus 3 and x minus 4 plus, we're just gonna leave this the same and leave this the same. So that idea that I said earlier about making all the same denominators and being able to get rid of it still applies here. So when I look at 2 over x minus 3, I notice that it's missing an x minus 4. So I multiply the denominator and numerator by x minus 4. When I come over here, I notice that it's missing an x minus 3, and that I need to do that to the numerator as well. So now I'm going to get my yellow and just be a little dramatic and show, oh, look at that. All 3 of my fractions have the same denominator, so I'm able to take all the denominators out, because if I did multiply by x minus 3, x minus 4 for each term, I would be able to eliminate my denominator. So I'm left with 5 plus 2 parentheses x minus 4 equals 5 parentheses x minus 3. I can distribute, and get 5 plus 2x minus 8 equals 5x minus 15. Combine like terms. 5 minus 8 is negative 3. And look at this. I am ending up with a nice linear function. So I'm going to subtract 2x. So I get negative 3 equals 3x minus 15. When add 15, and I get 12 equals 3x. Then I'm going to divide by 3, and I get x equals 4. So all that work, but it works out really nicely in this problem. So I just really advise that this idea of canceling out the denominators or just dividing it out is a really nice technique to deal with this. However, if you are doing something a little bit more simple, like number 4 or number 3, and even number 1, that cross multiplying is definitely a quicker way to do it. So I hope you found value in this video, and just hit me up with any questions.